Dear students, under the lecture series on complex analysis, we are solving problems under the topic Taylor series expansion. Here we have problem 4. The question says that expand cos z into a Taylor series about the point z equal to pi by 2 and also determine the region of convergence. As the first step, we shall write the Taylor series expansion about the point z0. So the Taylor series about the point z0 is given by f of z equal to f of z0 plus f dash of z0 by 1 factorial multiplied with z minus z0 plus f double dash of z0 by 2 factorial multiplied with z minus z0 the whole square plus f triple dash of z0 by 3 factorial multiplied with z minus z0 the whole cube, and the series keeps on going like this. Now we shall find each of these terms and substitute over here. We are given that f of z is cos z, that is the function to be expanded is cos z, so we have to take it as f of z. So when we substitute that here, we get cos z to be equal to f of z naught. Now what is z naught? Z naught is the point about which the series has to be expanded. Here the series has to be expanded about the point z equal to pi by 2. So we have to substitute f of pi by 2. So f of pi by 2 plus f dash of pi by 2 by 1 factorial multiplied with z minus pi by 2, since z naught is pi by 2, and plus f double dash of z naught. So f double dash of pi by 2 divided by 2 factorial multiplied with z minus pi by 2 the whole square plus f triple dash of pi by 2 divided by 3 factorial multiplied with z minus pi by 2 the whole cube plus etc. The series keeps on going. We wrote this because the function f of z is cos z and the point z naught is pi by 2. So having this, we have written the Taylor series expansion. But we are yet to find f of pi by 2, f dash of pi by 2, f double dash of pi by 2 and f triple dash of pi by 2 and substitute here. For that, first we shall find the derivatives of the given function f of z, which is equal to cos z. So first we shall take and write f of z for that. So f of z is cos z. What is f dash of z? It will be equal to the differentiation of cos z, which is minus sin z. From this we can obtain f double dash of z. The differentiation for sin z is cos z, and because of this minus, we will be having it as minus cos z. And then f triple dash of z is the differentiation of this, which is the differentiation of cos z is minus sin z, and since already we have a minus, it gets multiplied and it becomes positive and we get sin z. Now from this, what is f of pi by 2? That is, at the place of z we have to replace by pi by 2, which is equal to cos pi by 2. And we know that cos pi by 2 is cos 90, which is 0. Similarly, from this, f of f dash of pi by 2 will be equal to minus sin pi by 2. We know that sin pi by 2 is 1. And since because we have this minus here, it will be minus 1. And from this, f double dash of pi by 2 is equal to cos pi by 2 is 0. So this becomes 0. And then from this we have f triple dash of pi by 2, which is equal to sin pi by 2. And what is sin pi by 2? It is 1. And this is actually minus cos pi by 2, and because cos pi by 2 is 0, we are having this minus. So now we shall substitute these values, that is 0, minus 1, the 0 and 1 in our expansion. So therefore the expansion turns out to be cos z is equal to, so cos z is equal to, what is f of pi by 2? It is 0. So then we have f dash of pi by 2 which is minus 1. So minus 1 by 1 factorial multiplied with z minus pi by 2. And then f double dash of pi by 2 is 0. So because this is 0, this term vanishes. F triple dash of pi by 2 is 1. So therefore we get plus, here it is 1. So 1 by 3 factorial z minus pi by 2 the whole cube. So since here we had a minus, probably the next term will be a negative term, and it may be alternatively positive and negative. And we observe that we have only the odd powers for z minus pi by 2. So therefore this expansion will be minus z minus pi by 2 by 1 factorial plus z minus pi by 2 the whole cube by 3 factorial. So obviously the next term will be a negative term, and we can predict that the next term will be z minus pi by 2 the whole to the power. Since we have odd power, the next odd number is 5 divided by 5 factorial plus etc. It keeps on going like this. So this is the expansion of cos z in the into Taylor's series about the point z equal to pi by 2. And this question is also followed by another question where they are asking us to determine the region of convergence. And we know that trigonometric functions are analytic everywhere. So therefore, since it is analytic everywhere, the series is valid throughout the complex plane, and therefore the region of convergence becomes the full complex plane. So we can conclude by saying that this expansion is valid throughout the complex plane. In our previous problem also we had an exponential function e power z, which is also analytic everywhere, and therefore that expansion is also valid throughout the complex plane. So the complex plane becomes the region of convergence for this such series. So kindly follow the upcoming lecture for some significant problems from question paper. Thank you.